And first thing this afternoon, we want to talk about NAT, Network Address Translation, which is a function of IPv4. If you recall from last week, IPv6 does not have NAT. So we have all of them are public addresses. NAT is considered a security protocol because if you think about it, if we're trying to get to something, when we would get up to the firewall, it's like, where do I go now? Because the entire addressing scheme has changed. Let me try to do something. We'll give it a shot anyway. But if we have our cloud out here that we're trying to prevent connections from, and we have a bad guy here that comes up to our firewall, and I never can get the bricks drawn in there right. So, ugly firewall, but a firewall. And back here we have our trusted network or a private network, which is going to have private IP addresses on it. When we get to the firewall, the router, the NAT device, we translate from a 192.168.1.1 or 1.10, so 1.1 is probably the gateway, to maybe a 73.12.16.4. And then we go on the internet with this 72 or 73 address, goes through the cloud. Bad guy tries to follow this thing back. Once it gets here, hey, I'm trying to penetrate and get to the 73 address. Well, the 73 address only exists out here. In here, the 192 addresses exist. So it is a security protocol, as well as it has leveraged the use of, or allowed us to continue using the IPv4 address space, because we have 4.33 billion addresses. They're all been issued. If we didn't have NAT, all of the companies, ECPI used private IP addresses, Blue Ridge used private IP addresses, not really big corporations, really big companies. 400 or 500 users in each one, so you're talking about 1,000 addresses here, 1,000 addresses there. Once you start adding up the addresses that are saved by using NAT, it becomes pretty significant. Even on your network, on my network, my little network here, we've got a computer that I'm on, a laptop, we've got 2 televisions, 2 tablets, 2 phones, and occasionally we have visitors. So how many addresses would I need were it not for NAT? And in my case, PAT, port address translation, which is just a special case of NAT. We're going to translate from a private to a public so that we do have the security and we do have the leverage of the IPv4 address space. We can do more available for them. So NAT mechanism for translating the internal IP addresses to the external addresses. And when we're talking about internal addresses here, we're presuming that we're using private addresses. And this one's showing the 10 network is going to translate it to the 170 network. Conceals the internal addressing schemes. And this is one of the things that a number of security specialists don't like about IPv6. IPv6, everything's public. Everything that we use is a global address, a public address, a routable address. These private IP addresses are not routable, and they should never be seen on the internet. So we're going to translate them to a private to a public address, and we're going to have 3 different methods to do that. The host using the private IP address can communicate with hosts on the network, because now we're using a public address, a routable address to get there. Translates it to a globally unique public IP address, one that's been issued to us, and then the packets are sent to the internet from the internal host look like they came from the public IP address and not the private IP address. We're not routing here, we're substituting one address for another address. Here, actually, we're going to do a demo here in a few minutes. We have some kind of interesting terminology we'll talk about. Here is the source. Here is me. This is my IP address. I'm over here in the nice Carolina blue over here. The private IP addresses are called the inside local. The public IP addresses, mine, are called the inside global. So we got the inside address. Our addresses are the inside address. The other guy, the destination, the public, are called the outside global, and the private are called the outside local. And if we go to the other side, it's going to be flipped one way or the other. We'll never know what their private address is. The only thing that we'll ever be able to see is the public address. We have this terminology that's going to be used. And then when I do NAT, I'm going to NAT inside, and I'm going to have to specify whether the interface is an inside interface or an outside interface. And we'll do that in the demo here in just a couple minutes. And we'll look at a couple of the slides, and then then I want to do the demo. So the inside local address, the inside global address, the inside local address again here is the private IP address, the 10 address. In this case, the inside global address, the public address, the 200 dot whatever. The outside global is the other guy's public IP address, and the outside local is the other guy's private IP address. If we reverse the process, then we become the outside local and the outside global, and they become the inside local and the inside global. It's a matter of perspective when we do these things. So it depends on where we are, who we are, whether it's an inside or an outside address. That becomes significant when we start writing the NAT. We're going to have three different ways to do this. The first one is a static. The static would be used if we had something like maybe a web server inside of our network here. So we'll have let's have a firewall here. I'll try to draw some bricks on it. And we'll have a web server in here, and we'll have the cloud out here, which as you know I can't do very well. And the individual that wants to find a resource. The resource would be our web server. So we have a web server sitting inside our network. By the way, this is not the recommended way. This could be a customer. And we're selling widgets on this web server that's inside here. So we connect to our NAT device, could be a firewall, could be a router. The NAT device could be a concentrator of some sort, but we have a private IP address, 192.168.12.63 is our web server's private IP address. What we would have in the translation out here is maybe a 72.16.12.3 for the public address, and that gets NATed all the time to this address. They're connected together. This is one of the few reasons that you really would, I think, want a static address. Why would you want a static NAT? You've got a resource. You've got a web server. You need it to be the same address all the time. If we had a dynamic NAT, something that was changing all the time, today it could be the .3, tomorrow it could be the .7, the next day the .8. We'd never be able to keep DNS, which we will talk about next. DNS separated, actually. We do time next and then DNS. We'd never be able to get to that. So we want these to be constant so that we can have a specific IP address that always goes, public IP address that always goes to our private IP address. So that the customer goes to www.us.com and wants to buy a widget, he's going to go to this address in the public arena, and then that's going to be forwarded to this address on the other side of the NAT device. We can NAT either from outside in, or inside out. We normally think about it as inside out, where we're gonna go to the internet and we're going to use a private address. And when we go through our NAT device, we're going to get a public address to be able to go there. We can NAT in either direction, either from the inside or from the outside, inside out or outside in. Either way It's still a network address translation. So static is an implementation in which each private IP address used in the local network is mapped to a specific registered public address. Again, when would you want to use it? Typically when you got a resource that you want users to be able to get to. Otherwise, what's the big deal? If the CEO goes on the .17 or the .47 address. The IP address of a host within the local network is always translated to the same public IP address so that we can always get there by the static NAT. The NAT router maintains a static one-to-one mapping of the public to the private addresses. We'll look at one of those in a minute. The other one, the next one, is a dynamic NAT. We're going to have two ways to do this. One of them is going to be a pool of addresses, and the other one is going to be a single address, kind of like you and I have. So a pool of addresses where we have a number of public IP addresses. So we have a public pool, and the public pool may have, the whatever. I'm not going to do the first whatever octets, the .2, .3, .4, .5, .6 on down the line. In this pool, we add the addresses to the pool, like down here, and then when my private IP address comes up here, my private address comes up to the NAT device. Whichever one is available gets assigned to my private. So I go and go onto the internet through the cloud and get my resource. It comes back to the NAT table, and we'll have a NAT table which will have the IP and the port number of both of these guys, IP and port, so that each conversation can get properly delivered. When it comes back to the NAT table, the two public here, the public up there, the two public here goes to maybe the 3, or we'll say to the private address, so that the answer goes back to my private address. So we're going to have a NAT table that will do that. Once I'm finished with this one, it's no longer tied up. It gets put back into the pool. Advantage to the pool, the dynamic NAT with the pool, is that we don't have to have as many public addresses generally as we have private addresses, because you count on the fact, kind of like airplanes do, you count on the fact that everybody's not going to be going to the internet at the same time. If that happens, we'll talk about a way to overcome that eventuality also. Dynamic mapping of the private address to the public IP address. An address pool with a list of available public IP addresses is used by the dynamic NAT service, and then when a packet reaches the router from an internal host, the router applies the matching logic, and we haven't talked about that yet. The matching logic is, who gets a NATed address? Does everybody get them? We're going to specify, we're going to use an access control list to specify who gets to be NATed and who doesn't get to be NATed. Adds an entry into the NAT table showing the global address, and then it performs the NAT translation, and then it's going to route the packet. So we're still one private address to one public address. One private address to one public address. When the public address gets done being used, it gets put back into the NAT pool, so that the next guy up, next IP packet coming in, can now use that address. The NAT pool is just a grouping of the public IP addresses, a set of public IP addresses to be used by NAT, and the steps for the dynamic NAT configuration, IP NAT. And actually, I think I want to do this say, yes, they are here, and these are the things that I'm going to do or want to do in the demo. IP NAT pool. We're talking about the NAT pool. The NAT pool, the starting address and the ending address, and then the subnet mask that would go with those. One of the things that you got to be sure of when you get these addresses is that there's a route to them. Because it's just because you got a bunch of public addresses doesn't mean that people can necessarily get to you. They still have to have a route to that. PAT, port address translation, is a special case of dynamic NAT. It's a subset of dynamic NAT. When we were talking about IPv4, we had this thing that we talked about called a socket. A socket was an IP address and a port number. And we know that us at our machine, we use we'll say a temporary, because I can't, a temporary port, and we have an IP address. The IP address is assigned, so when we want to go somewhere, our machine, us, we create a socket. We create a socket with our IP and a temporary port. What happens when we get to the NAT device is it uses the same public IP address for everybody. Kind of like I do at home, and I'm sure you do at home. The same IP with multiple ports. That means we're going to have multiple sockets. And a socket becomes unique when we have an IP and a port, because we have 65,535 usable ports available, 65,536 actually, to do these things. So, but we had the well-known down at the bottom. We had the registered, and then we had the ones that we can use, here. So what'll happen here is down here in this, the inside local address, 10.253.1.6, port 2014, the socket here. So this is a socket, a unique location, an IP address. It's kind of like going to a doctor's office or an office building and then going to your doctor. The office building would be the IP address, and the room number for your doctor would be where you're going to for that particular service. It then gets NATed to a public IP address and a port number, which is a separate socket. So we have a couple of sockets here, socket being a unique location. Down here, the .7 address using the same IP address but a different port number. So it's a new socket, a different socket. And this one down here is socket number 3. So each of these have different sessions that we're connecting with from one to the other. The IP stack keeps track of those, and we can use a single IP address to connect multiple devices to. And I said that on the dynamic NAT, what happens if we run out? If we run out and we don't have an overload is the command that sets this thing up. If we're worried about that we may run out of IP addresses in the dynamic NAT, we can configure it to transition to port address translation if we run out of IP addresses in our and we'll do that here in a couple of minutes when we do that. So PAT, subset of dynamic NAT that uses multiple ports in order to configure these things, also called dynamic NAT overloading. It overloads the command that puts it into the PAT, the port address translation, or protects with PAT, maintains a dynamic NAT table, lists the port numbers mapped inside and the inside local and the inside global addresses that we're going to use these things. Maps several inside local addresses to one outside global address. Each of them has a different port number, and because they each have a different port number, the many-to-one PAT overloads NAT to enable many-to-one mapping of the IP addresses by using the port for this thing. So the steps here, and we can do that. First we'll define the interfaces inside or outside. We're going to do that when we get to the next slide, which is just going to be the picture of the thing that we just saw. Set up the access control list. Kind of mentioned that a little before. Who can get these addresses? And that's what the access control list is. And then configure PAT using the IPNAT inside source list interface on down the line in order to be able to do these things. The PAT configuration command refers to the IP address matched by the access control list and the IP address of when we do this. The overload option indicates that PAT is used to translate the IP address. Another method is using a NAT pool, and then at the end of it using the overload command. This is the same thing that we saw a little earlier. It's this one. What I want to do is to configure, first we'll do PAT, and then we'll do dynamic NAT. So when we do the configuration, and this is the one that we're going to configure it on. I'll show you a static over here. I'm just going to do the dynamics on this one. So we have, and I have them backwards. Fast Ethernet 00 is the inside, and Fast Ethernet 01 is the outside, which is really backwards to what I've said, and it's backwards to the little tippers that you could use for this thing, but it is what it is in this case. So we'll go to enable mode and do a config T, and do interface, Fast Ethernet, fast 0, fast, 0/0. Now this is my inside, so we have to label them as inside or outside. IP NAT, and it's going to be the inside interface. And then we'll go to interface Fast Ethernet 01. It'll be IP NAT outside. So out the tab on that. So we have now done those things. The next thing, and we kept hearing about who can actually get a NATed, and who can get a NATed address is whoever we allow. This network, and I'm just going to do the whole network back here, is 192.168.1 network. So I'm going to do an access list, and we haven't done those yet. Trust me, this is a standard numbered access list, because the only thing that we're going to worry about is the source IP address, 192.168.1.0, the network address. And then I'm going to use a wildcard mask, access list, access control list, and you do have to do them here, 0.0.255. What this says is check to see if we're on the 192.168.1 network, and any of the hosts, the 255s, the ones, any of the hosts are going to be permitted. The ones are, I've always said, the ones are, I don't care, the ones are in this case. So once we've done that, and the steps are on here, the PAT steps, label the interfaces, the access control list, and then we're going to enable NAT. So we're going to use an IP NAT. Actually, let me before I do that, let's see if we can get to, and I got 117.45.23.2 and 23.1. Let's see if we can ping, or what we can ping, how far we can get. We should be able to ping the one address, because it's directly attached to our router that we're using. Got the wrong ping, 117.45.20, or did I get them backwards? I get them backwards a lot. 45.23.1 is not getting there. 23.1 is the other side. Let me try, let's try the 23.2, which is us. We can do that. We can't get to the 23.1, which means that we're not being routed there. We just get a request timed out coming back to us. So yeah, I'm not going anywhere. If I NAT to that public IP address, the routable IP address, theoretically I should be able to get there, and if it goes right, it'll be more than theoretically be able to get there. We'll be able to do that. So back to what was going on, that before we NAT, we can't get there. So we'll be IP NAT, and we're going to NAT the inside interface. That's the addresses, the address set that we're going to be NATing, which are the private IP addresses. And then we're going to use the source list 1, access control list 1, that we configured here. The source list will be, if we had access control list or access list 17, the list here would be 17. So we have done that. We're not using a pool, so we're just going to NAT it to the interface, Fast Ethernet 01. It'll use the IP address of that interface, and then the overload command here, which says, hey, do port address. What I want to do here is show IP NAT translations, and we shouldn't have any yet, because they don't stay in here very long when we do them. And now let's see if we can ping the 23.1, and that was the one that we couldn't get to. It's on the other side there, right? The 23.1. Let's go back to this guy and hopefully show the IP NAT translations. The inside global, the public address 117.43.23.2, and then the outside, or the inside local, just to try to show, and this one sometimes works and sometimes doesn't, I'll tell you. let's just ping with a -T, which means it's going to keep going, and then ping with a -T on the other guy, and see if we can see that it uses T, so we get a whole bunch of these things. T, I hope. Spacing all wrong. I've really made a mess out of it. So now then, when we go in here and do this again, and I may or may not be able, I got the .2 here, I'm not seeing my .1s because they probably already were there. It's just keeping going. Actually, I am too. Here are my ones, 1.3 and 1.2. Looking at the wrong one. I was looking at the NAT here. So we have the 1.3 address, port 15, and each of these comes up with a unique socket, a unique combination. Goes to 23.2, port 1024, and then port 1025, the 1.3, and then it goes to 10. This is a packet tracer sort of thing. And then the 1.3, it got port 1 and then 20 and 21, 22, 23. So each of these IP addresses, the 1.3 and the 1.2, get translated to the same public IP address, but we have different ports. So we have different sockets are available. What I now want to do is to get back onto this thing, is to undo the NAT. We're going to have to do the label each time. We're going to do the access control list each time. So I'm not going to do those again unless you want me to. Do show run, because what I want to do is to undo the IP NAT, and I think that's the only thing that we actually need to change in this thing. So we'll go to config D and do a no, and then control V and paste. And we are there. I want to see something. Do show translations, and it still shows these here. I need to clear those. Let's try clear IP NAT translations, and I want to show you an error that says, hey, it's an incomplete command. And if I do the help, it says you got to use the asterisk in order to delete all of the dynamic translations. So once I've done that, show IP NAT translations, the reason is the other one's not going to work as long as there are translations in the table. Let's show IP NAT, an incomplete command, translations, and we have nothing there. So the next thing that we want to do, we label the interfaces. We did that already. We did the access control list. Need access control list. We did that already. Then we need a pool of addresses. The pool of addresses that we need. So it's going to be IP NAT, I think, pool. And then we're going to name the pool, the word. Let's just name them public. And then the starting IP address. Now let's use 117.45.23.5, and then after that the ending IP address 117. I'll just do a few here. 117.45.23. Let's use 10, and then we have to specify the net mask. And in this case, I think that you've got to type the word net mask, and then 255.255.255.0. I'm not going to give the overload command because if I do, it messes up the demo. We're just going to use these like this. In reality, you would use the overload command in case I ran out of, I've got 5 addresses here, 10 people try to get on. If I use the overload command after I used up the 5 addresses, the 6th person going to the internet would then go into port address. Let's try that same thing here. I can hopefully get there a little quicker. Maybe I can get here a little quicker because I think I probably already have the commands running here. Control break, because it's still trying to do, and since we're not natted anymore, it's not doing anything. So let's see if we can ping this guy and make a mess out of it. Timed out. That's never good. And it's acting like it's not going to work. And you know why it's not going to work? Because we have not, do a control break here, because we have not configured the NAT itself. In the what are we going to do? We're going to label the interfaces, access control list, address pool. Now we got to enable to do that. So what we're going to do with it, let's see if I can get there. We're going to do an IP, we'll go config, and do an IP NAT, and then after that, we're going to IP NAT, we're going to NAT inside, and then the source list 1, and after that, we're not going to do an interface, we're going to do a pool, that we'll type the pool, and I think I use public for the pool name, when we do that. We could use the overload command, but I'm not going to do that. IP NAT, I set the pool earlier. We didn't enable the NAT translations, IP, or the NATing. So I show the IP. Oh, we already got some here for 23.5 for the 1.3. So let's go to the 1.2. This is the one that I stopped a minute ago. And let's ping him. And now let's go back and see if it's going to do IP NAT translations. We got the 1.3 is the 5 address, and the 1.2 down here has got the 6 address. So we've now used 2 addresses out of the pool. Realistically, I should put the overload command at the end of my IP NATing statement where I actually activate NAT, so that if I should happen to run out of IP addresses, and that certainly could happen, that everybody decided to get on the internet at once, I would automatically go into port address translation and be able to continue working instead of, in this case, without the overload command. If I run out of, when I run out of addresses, I'm out of addresses. The next person's not going to get on. A number of labs here with NAT will go down the line here.